Imagine you're a part of a development and operations team responsible for managing a cluster of Linux servers. There are thousands of nodes on which configurations and setups must be consistent, updated synchronously, and reproduced very quickly. You cannot allow yourself any mistake or shortcoming when updating and applying the new config, because that could lead to a part of your infrastructure going down. Now, let's scale it down a little. This is Toby. Toby is a system administrator at a small company. One part of his job is making sure that the company's servers have the same firewall rules configured, same packages installed, and same public RSA keys for remote access saved. Toby spends his days manually updating old configurations, getting the new machines ready and running, and solving unexpected problems in the infrastructure. Toby gets tired of constant stress in his life and wants to automate this routine and save himself some time to learn a new technology or maybe just have a longer lunch break. Today, we're going to show you how Toby could do it. How to manage IT infrastructure without having to constantly visit the server room or connect to virtual machines via SSH. Not only Toby is dissatisfied with this amount of manual labor, his boss dislikes it as well. Here's why. Keeping a reasonably big infrastructure going is a costly business. You need to hire lots of people. Then someone needs to manage them. In their turn, those people will solve tasks differently, thus increasing the complexity of the system. It keeps operating expenses and salaries high. Having many different people managing and deploying configurations may result in some kind of compatibility problems. Manual management of the servers will eventually result in human mistakes, causing long downtimes. Inevitably, this level of complexity may lead to a nightmare dream of a particular sysadmin team, the snowflakes. Not that system administrators are afraid of snow, but a snowflake is a unique configuration that you can't reproduce automatically, which means you can only work on errors or bugs manually, which costs time and money. To avoid all these problems, a concept of infrastructure as code comes into play. We will put a link to Microsoft Azure documentation into a video description where the idea was described best. In the same way as identical code always generates the same binary, an IAC model always generates the same environment once deployed. That means to manage your infrastructure, you edit the code, not the target system. Turning configuration into code lets you go through phases of testing and approval in the same way it works with applications. You can run unit tests to find any bugs or defects, and check whether changes even work through the test infrastructure. Being able to work with system configurations this way, DevOps teams can create environments the same way developers create applications: fast, consistent, at a much bigger scale, and with a much higher degree of information or server availability than before. Automation is by no means the only concept of IAC, but since our topic is configuration management, we're going to concentrate specifically on it. Configuration management is a process of keeping all your software and hardware in the same state at all times. Instead of having each system administrator doing their custom scripting, configuration management tools automate this task, thus reducing cost, complexity, and avoiding many errors. Think of it as your Google Docs document with all the information about your presentation. Google Docs stores your text, links, ideas, and brainstorming for the presentation or video, keeps track of document history, makes your file available from any calculator with an internet connection, and also includes some add-ons in case you want to somehow change the default behavior of the application. Configuration management tools are exactly like it. They help you keep track of services you're running on your infrastructure, as well as their states, version history, and purposes for deployed changes. It helps you avoid undocumented changes to the infrastructure, thus keeping track of its state at all times. Again, these tools turn the management of your infrastructure into a code that's deployed across the whole network, generating the same environment everywhere it's executed. Also, since configuration management has become so broadly used over the years, even the simplest tasks like opening a port can be automated, as well as the hardest jobs like setting up a new server from scratch now only takes minutes. Toby can now use configuration management tools to automate his usual routine and go have a longer lunch. Or he can use his free time to deepen his knowledge about Puppet or Chef, which we are going to walk you through in the next part of our presentation.